Hello guys, a very good day to all of you. In this video, I'm going to show you how I make a compass error calculation. I made this video for all the marine newbies out there who find this topic a little bit confusing. So, just relax, this won't take long, and without further ado, let's get into it.
Okay guys, so now we gotta start for our computation for the compass error. And please guys, don't forget to subscribe. And this is our traits. Okay, so let's start. Compass error calculation. So first, we're gonna need all these: date, time in UTC, latitude, longitude, gyro bearing, gyro course, magnetic course, and variation. For the date, yes, we gonna need the GPS from here, 20 of November 2019. Then the time in UTC, 1500, 01 minutes, 38 seconds. The position, the latitude and longitude. The gyro bearing, which is 267 degrees from gyro compass. And yes guys, that is me. Yes. Gyro course, we take it also from the gyro compass, which is 118. Magnetic course, of course, from magnetic compass, and the variation from the ICDIS. So I'm going to explain to you how I get this value out of this data. Okay, here we go guys. We have here the reference year for the magnetic variation, which is 2015. This is the year that this data was taken. And we have the current year now, which is 2019. We bring it down. And also, we bring it down, the 2015, the reference year for magnetic variation. We subtract them, always. We get 4. We bring down the 6 minutes here, which is the value of annual change in magnetic variation. We multiply them and we get 24 minutes. We divide by 60 and we get 0.4 degrees east. And why east? Here, the value here is positive. Now we have rules here. If the value is positive, then the name is east. But if the value is negative, then we name it west. For now, we have a value here positive, so it's east. And 22 degrees from the value of magnetic variation, which is negative here. So, as per our rule, if the value is negative, then we name it west. Of course, we have rules here. If same names, add. If different names, subtract. So we have different names, so we subtract. And we get 21.6 west. Okay, for the naming of this, just only take the name of the larger value between these. And this is it. This is how we come up with this value, 21.6. Okay, so minus 7 seconds. What is this? This is from the stopwatch. This is the time that you take from on reaching on the GPS from the gyro repeater. Okay, we subtract it on 38 seconds and we get 31 seconds, and this is now the sequence that we're going to use for the rest of our calculation. So now we take the value of the GHA. We're gonna need the data from before, and also the page from the almanac, and this is the nautical almanac. Here, this is the dates, and the date here is 20 of November, and here it is, and we're gonna use the 1500 hours from our time, and here it is, and its value here, it's 4836.7. This is the GHA of the sun, because we are using the sun. Okay, for the value of increments, also we're gonna use the nautical almanac. It's yellow page, the increments and corrections. Yes, we're gonna need the minutes of our time. This is the minutes of the page. You see here 0 minutes, 1 minute, and so on. Okay, so we have 31 here, which is our seconds, and the value of the sun is 22.8, and that's what we're going to put here, the increments, 22.8. Now the rule here is always add to take the true GHA. So we add them, we get 048 degrees, 59.5 minutes. The longitude from the data that we've taken before, which is 011 degrees 23.7 minutes east. Okay, so we have a rule here in order to take the LHA. Number one rule is that if longitude is east, we add. If longitude is west, then we subtract. So because it's east, we add, we get 059 degrees and 83.2 minutes. Okay, remember guys, because 1 degree has only 60 minutes, so what do? Is to subtract 60 from this 83.2 and add 1 degree on this 059 degrees, and we get 060 degrees 23.2 minutes, and that is now our LHA. Okay, so we are going to take now the declination, its correction, so that we could take the true declinations. Okay, so still we're gonna need the nautical almanac for this, and of course this page from before and this data from before. November 20, 1500, okay. So the value here is the declination, 19 degrees. Where did I take this? Here, because as you can see, 19 degrees, they're all just the same. So 19 degrees, it's 19 degrees here, and of course that one, then the 42.5, which is the minutes. Okay, and the name is south. See the name here, it's south. D correction. The D correction, we will find it here. This is the D correction for the declination of the sun. So the value is 0.6, so we put it here, 0.6. And we put the plus sign. Why? It's because here we are here 42.5, 42.5, and of course we have a rules here. If number one rule, if the below value here is increasing, then put at or plus sign. If the value below is decreasing, let's say from 42.5 to 41, then it's decreasing, so it means you're going to subtract. Of course, the sign of the subtraction is negative. For now, we're gonna use positive because we're going to add. Okay, so for the D correction, we're gonna use the yellow page, increments and corrections from the Nautical Almanac. Of course, the data from before, 01 degrees minutes, yes, and the D correction, which is 0.6 here, is the D correction. And the V correction, remember guys, this V correction is the V correction for the GHA of the moon, but we're gonna use the declination of the sun, which has a D here. The value of D is 0.6 and its data is 0.0. Remember guys, because some other value of D is somewhere here, 3.0, 3.1 or 3.8, that we have a value of 0.1, but for now we have a value of 0.0, but for the sake of calculations we're gonna include it. Okay, so here it is, we put it here. Now the plus sign, why? Where is this coming from? From here. Okay, then we add, of course, 19 degrees 42.5 minutes south. Okay, from the name of the declination. Okay, so now we're going to find the value of ABC, and we're gonna need the nearest nautical tables. First, we're gonna find the value of A from the table A. Yes, and this is the local hour angle. We're gonna need this value of our local hour angle, or most commonly known as LHA, and these are the value of all the LHAs. And looking from our LHA value, which is 60 degrees, we are somewhere right here. Okay, so latitude, this is the line of value of latitudes, yes, and we're gonna need the data from 4, the latitude, which is 31 degrees 23 decimal 2 south. Yes, LHA first here, and 31 degrees here, so their intersection is 0.35, and that's what we're going to put here on the value of A. And how to name it? We name it north because here the rule is name opposite to the latitude, except when the LHA is between 90 degrees and 270 degrees. I'm gonna explain it further. Here it is. Okay, for the local R angle, name opposite to the latitude except with the LHA is between 90 degrees and 270 degrees. Our LHA, our latitude. Okay, try to draw this in your mind. Okay, of course, 0, 90, 180, 270. Here, from 90, 180, 270, same name. From here, 90, 0, 270, change name to opposite. Because our LHA is somewhere here, it means that it's in the area of change name to opposite. The name of our latitude is south, so its opposite is north. That's why we have the name north on RA. Okay, so now we're gonna find the value of B from table B. Of course, still we need the local R angle, the LHA, and now at this time we're gonna use the declination. We have here LHA 60 degrees, and also we have here our declination, which we make to 20 degrees, and we have the intersection here, which is 0.42. This is what we put here for the value of B, and we name it south because here we have a rule: always name the same as the declination. The name of our declination is south, so we take it from here down here to our B. That's why our B have a name south. Okay, to find C, of course we have a rules here. If A and B have the same name, then we add. But if A and B have different names, as we have now, then we subtract. So we subtract and we get 0.07. Now, naming of C. We have rules. Number one rule: if A and B have the same name, C takes their name. But on the number two rule, if A and B have different names, as we have right now, then C takes the name of whichever is the larger. And with this, our B has a larger value, so we take its name, which is south. So we take south. Now it's time to take the Z in, which is the azimuth, and we take it from the table C. Of course, from the Norris book, the table C, and we need the latitude from the data before. This is our latitude, which is 31 degrees, somewhere here. And this is the value of our C, which is 0.7, and the intersection is 86.6. We put it here. Okay. For the naming of Zn. For the naming of Zn, we have two names. First, north or south, depending on the name of C. So the name of C here is south, so we just put it here, south. Okay. For the second name, east or west, depending on the value of LHA. This is the value of our LHA. How do we do it? We have two rules again. East, if the LHA is between 180 degrees and 360 degrees. Second rule, west, if the LHA is between 0 degrees and 180 degrees. So try to draw this in your mind again. 0 degrees, 90 degrees, 180 degrees, 270 degrees. From 0 degrees to 180 west, from 180 to 360 or 0 degrees east. So, because our LHA is somewhere here, so it means it's in the area of west. That's why we put here west. Okay, so now we're gonna take the TB, which is the true bearing. Okay, try to draw this diagram in your mind again. This is very good diagram. Yes, northeast, southwest. Here, northwest, southwest, southeast, northeast. True bearing is equals to Zn in northeast. In southeast, true bearing is equals to Zn minus 180. In southwest, the true bearing is equals to Zn plus 180. And in northwest, the true bearing is equals to Zn minus 360. Because we have south here, we have west here, we are here, southwest. And so, we're gonna use this formula. True bearing is equals to Zn plus 180. Here it is. So, the value of Zn, which is 86.6 plus 180, and we get 266.6. Now, we have the true bearing. And we're gonna use this value on our next calculation for the deviation. Okay guys, that was the part 1 of our calculation for the compass error, and part 2 is already on its way. So be sure to click that subscribe and bell button so that you will be notified as soon as I uploaded the second video. Okay, so guys, I hope that you get something in this video, and I also hope that it could somehow help you in your days ahead with your career. Thank you guys. See you next time.